Now under types of trusses, I am going to cover the second one is shear truss. This shear truss is indicated by tau like this. So how to define this? Before going through the definition of this one, now let us consider a body like this. Let us assume this is x, y, p, r. On this surface I am going to apply the load like this. Next, on the bottom surface I am going to apply the load like this. These two are the externally applied forces. These two forces are acting parallel to or tangential or along the plane PR and XY. While telling you the definition of shear truss, I gave the example of this one. Shear truss is nothing but the truss which acts parallel or tangential to the surface is called as a shear truss. Here this load is acting along the plane or parallel to the plane or tangential to the plane, so it is called as a shear load. Shear load. This shear load divided by corresponding area gives shear truss. This is a corresponding area on which this is acting, this force is acting. Now I will try to analyze this internally. This is our body, x, y, p and r. Now I am going to cut this by a section plane CD. Now I will consider the top portion. This is our top portion XY. Here I am applying the load F. This is the externally applied load is F. So internally what is going to happen? The forces will going to set up in order to oppose the what? This externally applied load. That force will be exactly opposite to the what? Externally applied load. This is a internally applied load. Sorry, this is a internally developed force. This is a externally applied load. Okay, this internally developed force is exactly opposite to the externally applied load. For the equilibrium of this body, this portion, whatever the externally applied force is there, that externally applied force, whatever the internally developed force is there, that internally developed force would be equal to the what? Externally applied load. So nothing but for this body to be under equilibrium, the internally developed forces should be equal to the externally applied forces. So now how to define the shear truss now? Shear truss is shear load or resisting force divided by area. So resisting force is what here? This is F dash, area is A. For the equilibrium of the body, this body or this portion, the internally developed force will be equal to the externally applied force. This is the externally applied force and the corresponding area gives the value of the shear truss. The unit of this one is Newton per mm square. So what is the meaning of shear truss? The shear truss always acts parallel or along or tangential to the surface. Those kinds of trusses are called as shear trusses. Now I'll take an example of this chalk piece. This is a chalk piece. What I do, I'll try to apply the load like this, exactly parallel to the what? This surface. I'll try to apply the load parallel to this surface. Now see here, this is a load. What kind of load it is? This is shear load, because whatever the apply load is there, that load is parallel to the what? This plane. So these kinds of loads are called as a shear loads, and the corresponding stresses are called as a shear stresses. It will try to shear the material. This principle is basically employed in sheet metal to cut the sheet metals in punching operations. See here, this is a paper. See here, what kind of load I am applying here? Whatever the load applied is parallel to this surface. So this is a shear load. Cutting up a paper with the help of a scissor, that is also an example of shear load.